Hello guys, welcome back to my channel. This is Nikhil Maripalli. Previously we have seen how to implement logistic regression model from scratch. Today we are going to see how to implement KMeans, which is a unsupervised machine learning technique from scratch. So basically the machine learning models are divided into three categories: supervised, unsupervised and reinforcement learning. So supervised learning is where you have a target variable. Suppose if you are building a classifier to predict whether the image is a cat or a dog. So you have the label and your task is to predict any of this, like if the image is a cat or a dog. And unsupervised learning is mainly used to cluster the data. So suppose if you have images of cats and dogs, like different breeds, your model tries to cluster all the cats together and all the dogs together. This is a kind of unsupervised learning. So the unsupervised machine learning models are further categorized into two types. One is principal component analysis and the other one is clustered analysis. Principal component analysis, also known as PCA, is a dimensionality reduction technique where you transform the data from higher dimensions to low dimensions, and these lower dimensions are still able to capture most of the important information of the data. K-means belongs to the clustered analysis. I'll go through the use case of a K-means with an example. So suppose you are a bank manager and you are working on loans. So to grant a loan to a particular customer, there are different features you need to look, like the FICO score and the number of accounts he has, and one of the main factor is the income. So if you look into each individual and try to make a decision, that involves huge amount of time, and this is not a reliable process. We can actually do better with the help of clustering. So what we can do is we can cluster people based on their income level. Suppose like 20 to 60,000 come into one cluster, and 60 to 1,20,000 come into the other cluster. So based upon the cluster number, we can actually allot the depth to them. This would be easier for the bankers to make a decision on a particular individual. So as we have seen a use case for K-means, now we will look at the steps K-means performs. So initially we'll be choosing a number of clusters, say K, and I'll show you later how we can actually get an optimal number for K. So we select K clusters. Here it is 2. We treat them as centroids. Here C1 is one centroid and C2 is another centroid, and you calculate the Euclidean distance from C1 to all other data points and C2 to all other data points. And depending on the distance, which suppose for this data point the C1 distance is less than the C2, so it is categorized into one, it treated into one cluster, and this particular data point is closer to C2, so it is treated into the C2 cluster. So now as you have two clusters, now you again calculate the centroid. So basically you actually take the mean of all these data points, and that will become the new centroid. And again for these three data points you actually calculate the mean, and that becomes the new centroid. So this process repeats until no centroids change or the number of iterations are completed. So guys, as the theoretical part is done, we will move to the implementation part. So for this I have created sample data using make blobs, which created three centers. Our objective is to cluster the similar data together, so we'll be using k-means. So typically I'll be following the same steps discussed above. I'll be just implementing it. So I'll create a class called k-means, then init. So init takes two arguments. One is the number of clusters and the max iterations. I mean till how many times you want to repeat this procedure. Self, okay, I'm giving default parameters, and max iters is equal to 100, and then you just initialize them. And we also need here two more things. One is the centroids, the other one is the clusters. So here we don't have any fit method like we used to have in logistic regression. There is only predict because actually there is no training required. You just find the similar features and you just group them together. So basically we don't have any fit method here because there is no training required. We only require the predict method. So sample indexes as I showed above, we randomly select 2 points as centroids. So I am doing that here. Uh, so from this samples we are taking k as I mean 3 points as centroids. Okay. So assign data points is a method which takes in all the data points and it finds a Euclidean distance between these centroids and returns them. So we'll just define that function. We'll define a method called find closest centroid, which actually finds the Euclidean distance and returns the closest centroid. So which takes in two arguments, one is sample and the other one is centroids. So okay, and what it does is the clusters is, so what we are doing is we are creating three clusters, right? As we chose k is equal to 3, and we for each sample we calculate the Euclidean distance, and for the closest one we append it. We append the data point. So initially you can. So initially it will be like after declaring here, you'll just have three empty clusters. And then suppose after this, if you take a sample, it might look like one sample is attached to appended to third cluster. Okay, and we just return the clusters here. Okay, so we'll define the find closest centroids. Yeah, and we also need to define the Euclidean distance. So you define the Euclidean distance here. No, we'll define it up. It basically x1 minus x2 whole square and y1 minus y2 whole square. So yeah, okay. Yep, so it returns all the distances between the centroids and the samples. Then and we take the minimum distance. Suppose this distances are like 3.5 comma 6.7 comma and 1.4. So argument will return the index of the third sample, so which is 3, and we simply return the closest index, and which returns 2. Sorry, yeah, 0 1 2, right? So it's 2. So next what we are going to do, as we got the clusters now, we just save the old centroids. I'll tell you why. uh, and we calculate the new ones. So how we calculate, we just take the mean of all the samples, and that will be our the new centroid, so which just takes centroids as parameter, self sorry the clusters, because we have to find the mean, right? Then yeah, we'll create a method, get new centroids self comma clusters. So centroids, we calculate the mean, np dot mean of all the sample points in that particular cluster. That particular point will be chosen as the centroid, new centroid, and we just return the centroids. Okay, now as we have the new centroids also, what we need to check is when we stop the iteration, that is when there is when it is converged, when the centroid's position doesn't change. So we also need to give that condition. So that's why I saved the old centroids. Now if this condition is met, we simply break out of the loop, because this is the last step, because we loop out if is no centroids change. Okay, we just calculate the Euclidean distance between the old centroid and new centroid. and sorry, and this particular distance, it should be, the sum should be 0, and we just check for this condition. Yeah, that's it. We pretty much made it. We can also define a plot function, which actually plots after each iteration. We can look at the centroids. Okay. We represent centroids with this symbol X, and the color would be black. uh, SPLTR. So yeah, pretty much everything is done. Now, okay, and yeah, yeah, finally we need to return the clusters, right? So just return the clusters. So I defined a function called final clusters. So it actually returns you the clusters with the data points. So what it does is it takes a labels list, and for each sample it finds a cluster ID which was assigned to, and it returns the labels list. Okay. Yeah, we are done. So hope everything works fine without any errors. Just initialize the class with k equal to 3 and max iterations is 150, and vibrate, this is going to just predict k dot predict x, and we are going to just plot it. Yeah, so initially this is how the clusters look like. These are the centroids. We had 3 centroids, right? So, and you see it was initially not good. Then You could see how it's changing because of the Euclidean distance, and they calculate the new centroids and they group them together. And this is how the final centroids look like. That's it, guys. We have implemented K-means from scratch. You can now play around with this notebook, and you could also use the iris data to get started with it. And yep, thank you.